Today, we're going to crack the code on how scientists write those ridiculously big and incredibly small numbers, without their hands cramping up.
I mean, seriously, whether you're talking about the cosmos or something you can only see with a microscope, you end up with these numbers that are just, well, they're a total handful.
For example, check this out. This is the mass of our planet in kilograms. Yeah, I'm not even going to try to say that number out loud. Just look at all those zeros.
And then on the complete opposite end of the scale, you've got something super tiny, like the diameter of a single blood cell. Still just as annoying to write down, right? But for a totally different reason.
It's just messy. It's so easy to miss a zero or put the decimal in the wrong spot. Honestly, it's just not practical. There's got to be a better way, right?
Well, there is, and it's called scientific notation. And honestly, you can think of it like a secret code for these massive and tiny numbers. It's way cleaner and way more efficient.
Okay, so the official definition might look a little intense, but trust me, the idea behind it is super simple. All we're doing is taking any number and packaging it up neatly using a power of 10.
So, how do we do it? It's literally just 3 easy steps. First, you're going to move the decimal point so there's only one digit that's not a 0 to the left of it. Then, you just count how many jumps the decimal made to get there. And finally, that number of jumps, that becomes your exponent. That's it. Simple as that.
Okay, let's go back to the mass of the Earth. We take that invisible decimal at the end, and we jump it all the way over, 24 spots to the left, until it's right after the 5. So now we have 5.98, and since we jumped 24 times, it becomes 5.98 times 10 to the 24th power. Look how much cleaner that is.
And here's a super simple rule to remember. For big numbers, anything greater than 1, the exponent is always going to be positive.
All right, so what about that tiny blood cell? Same deal, but this time we move the decimal to the right. We jump it 1, 2, 3, 4 spots to get 7.5.
And here's the other part of the rule. Since we started with a really small number, less than 1, our exponent is negative. 4 jumps to the right means our exponent is negative 4. See? Super easy.
Okay, so this is great for cleaning up our notebooks, but is it actually useful in real life? Oh, absolutely. Let's look at an example that's, well, surprisingly close to home. So, get this. Your hair grows at a speed of 1.6 times 10 to the negative 8 kilometers per hour. I mean, what does that even mean? It's such a tiny number, it's pretty much meaningless to us, right? So, how can we make it make sense? What does that abstract number actually look like in a way we can, actually understand? Well, that crazy small number works out to about 1.2 centimeters a month. See? That tiny scientific number means your hair grows about this much every single month. Now that is something we can actually picture. And that's the real magic here. Scientific notation isn't just about making numbers shorter. It's a tool that helps us understand the world around us, from something as massive as a planet to something as small as our own hair. So, I've got a little challenge for you. What's the biggest or smallest number you can think of? Maybe the distance to another galaxy? Or the size of a single atom? Go on, try writing it out in its secret code. Give it a shot.